Getting started with 2.3, we'll start with 2.3a as an alpha, and we are going to start doing what they call applications, but we know it as the dreaded phrase, story problems. Dun, dun, dun. Anyway, story problems are hard for everybody. I've never met anyone who enjoys story problems or finds them easy. So what we're going to do is we're going to just struggle through this. And I want this to be an encouragement that everybody struggles rather than a discouragement that everybody struggles. But top of page 131 gives you a blueprint for problem solving. Now, those are really important steps, but it doesn't necessarily mean that each of those steps are easy to figure out. So yes, obviously, step 1, read the problem. That's not a problem. Step 2, assign the variable. Yes, that is one of the most difficult things. Step 3, rewrite the problem, then write an equation. It just makes it sound like, oh, it's just as easy as that. Write an equation. But that is the hardest part of a story problem. Once you have the equation, it's easier to solve it. Not easy, but easier to solve it. So then you write your answer, All right, so one of the things that I find to be very difficult is to come up with the variable. What is the variable? And what I usually tell students is the variable is going to be the item or the thing in the problem that you know the least about. You have the least amount of information about. And a lot of times, well, pretty much all the time, you can tell what that is because everything else in the problem is being compared to it. So let's look at example 1 and I'll explain what I mean. The length of a rectangle. So one of the steps is to draw a picture of what you've got. I think that really does help. Plus, it kind of gets my mind off solving the problem and allows me to be distracted by drawing the problem or drawing a picture, and then I don't have to do the problem right away. It's kind of like before you have to do something really bad, all of a sudden, oh, great, oh, I have to go to the bathroom or something. It just kind of puts it off. So we draw a picture, and it says the length of a rectangle is 3 inches less than twice the width. All right, so what are we comparing to? We're comparing the length to the width. And we're given some information about the length. It's 3 inches less than twice the width. So what we know the least amount of information on is the width. We know nothing about the width. The length, we know that it's 3 inches less than twice the width. So if we took twice the width and might subtract 3 from it, 3 inches less than twice the width. So now we know what the length is because we compared it to the width. And the width we knew the least about, so it's real easy to assign that a W or an X or whatever variable you want, and then write what we know about the length. Okay, so that's some of the hardest parts. The perimeter is 45 inches. So we know that P equals 45. And there is a formula for the perimeter of a rectangle, and it's 2 times the length plus 2 times the width. So we look at this formula, knowing that bit of information, and we are going to assign, instead of an L here, we're going to assign 2W minus 3 to that because, like I've said before, if you have one equation in 2 variables, you cannot solve it. So if I can make this L into a W, then I have one variable, W. It appears twice, but it's only one variable. So I'm going to fill in the blanks with what I have. Perimeter is 45, 2 times. And we have that. And then we just do the algebra from there, and hopefully this is the easy part. If you can read my writing while I'm doing it, I guess that could make it hard. Add 6 to both sides. So 51 equals 6W, and then we divide by 6, that goes away, and our W is 51 over 6. But lengths, you usually don't leave it as a fraction. You write it as a decimal because 8.5 makes more sense to the reader than 51 over 6. Now that's the width, is 8.5. Now you have to find the length here. So we take 2 times whatever the width is, in this case 8.5, and then we subtract 3 from it, and that gives us 14. So our length is 14, and our width is 8.5. All right, let's look at example 2, middle of page 132, and let's kind of follow the same idea that we did before as far as what we're looking for. So we read the problem a couple times if necessary. There are going to be things in story problems that you don't need to solve the story problem. In April, Pat bought a Ford Mustang with a 5.0 liter engine. I mean, obviously 5 is a number, but we don't need that. The size of the engine does not matter for what we're looking for. The total price, which includes the price of the car plus sales tax, was $17,481.75. Most of the time, it helps me to write down the information and assign what that is. So this is the price plus tax. Okay, a lot of times they'll say the price out the door, meaning after everything is paid for and you're taking it with you, how much did you pay? Sales tax was 7.25%, and I also like to write this as a decimal because one of the things that you're going to find out, 7.25% gives you the tax, but very, very rarely will you ever use 7.25% while you're doing the math. If it has the percent sign, 99% of the time, you're going to have to change it to a decimal. So if it's given to you this way, with a percent sign after it, know that you're going to have to change it to its decimal form so that the percent sign isn't there, and then you can do the math. So don't try to do your math with the percent sign there. All right, so what we're looking for then is, let's just call it X. We're looking for the price of the car. This price that we're looking for is the price that you looked at the car for, and it's without the sales tax. So what we're going to do is we're going to start assigning some value here. This price right here is the price of the car times the sales tax plus the price of the car. So what that means is, let's just put this aside for right now. Let me get it out of here. Let's say that you bought something for $10 and the sales tax was 5%. So that means the sales tax was 50 cents. So you paid $10 for it, sales tax was 50, that gave you $10.50 is what you actually ended up paying once you put the sales tax in. So this is the price, this is like the X, this is the tax, and this is the tax plus the price X. So how did we get the tax here? We took the price times the percent, or the percent of the sales tax. The percent sales tax was 5%. So if we take 5% times 10, we get 50 cents. And then we add that 50 cents to the price of the item. And that's where we got our 50 cents plus $10 equals $10.50. So that's what we're doing over here. We are taking, let's find my eraser. We are taking the price of the car, X, and then taking the price of the car times the sales tax to give us how much money in tax we paid. And that will equal our $17,481.75. Let's get rid of some of this. Maybe I can't. So here is my full-on equation here. So now I'm finding x. So I'm going to add these two together and end up with 1.0725x, because this is 1. And that's going to equal my 17,481.75. And I'm going to divide by 1.0725. Those go away. And my x equals whatever that divides out into. And when you divide, it gives you 16,300. Now I'm going to have you look at page 133, Facts of Geometry, and top of page 134, Facts from Geometry, because you're going to need that information for some of these other problems. For example, example 3. Two complementary angles are such that one is twice as large as the other. Complementary angles are two angles that when you add them up, you get 90 degrees. So if this is 30, its complement would be what angle do I add to 30 to get 90? The complement of 60 is 30, complement of 30 is 60. So that when you bring them both together, you get 90. So let's go ahead and get rid of that and draw another one up here. So we've got a complementary, it's a 90-degree angle. All right, it says two complementary angles are such that one is twice as large as the other. What do we know the least about of information? We know the least about the other. We know one is twice as large as the other. So our other is going to be x. So I'm going to draw a line here. I'm going to make this angle x. This is our other angle. The second angle here is twice as large. So it's 2x. So find the two angles. If we take 2x plus x, we get a 90-degree angle, because two angles added up that are complementary are going to give you 90. So then you solve. And when you solve for x, you get 30. And that means that 2x is going to be 2 times 30. Add them both together, we get 90, so I know I did it right. So let's look at example 4. Suppose a person invests a total of $10,000. So you've got a total of $10,000, and what are you doing? You're investing it in two different accounts. So we're going to split it up. We're going to put some of it in one account, and one account earns 5%. So we're putting some of it in the 5% account. And we're putting some of it in the 6% account. I don't know why you would split it up when you're making less money here, but that's the story problem. All right. If the total interest earned from both accounts, so if we took the interest in both accounts and added them together, we would get $560. So let's look at this real quickly again. We have $10,000. We put some of it in here and some of it in here. At the end of a year, we get our interest from here back and our interest from here back. When we add them together, we've made $560 out of that $10,000. The question is, how much did I invest at 5% and how much did I invest at 6% in order to get that interest? So that's what I'm looking for. So the amount I invested at 5% is going to be, let's call it X. So I invested X at 5%. I'm just going to write it as 5% here right now. When I multiply these, that's the interest. So if I invested 5,000 at 5%, I would multiply 5,000 times 0.05, because that's what 5% is as a decimal, and that would tell me how much I made at 5%. I do the same thing with the 6%. So how do I find out how much I invested at 6%? Because if I invested X at 5%, what I invest at 6% is what's left over of that 10,000. So if I invested $4,000 at 5%, I have $6,000 left to invest here. So how do I write what is left after I invest at 5%? Well, I take my original amount and I subtract what I don't have any longer. I invested X at 5%. So 10,000 minus whatever X is going to be the amount that I have to invest at 6%. And that equals 560. So now I change this to a decimal, and I'll put the number first. And I will multiply this times, well, let's just change it to a decimal first before we multiply. Okay, so now I distribute that. 0.06 times 10,000. So I end up with 0.05x plus 600, 0.06 times 10,000, minus, because I multiplied that by that. All right, so now I continue to move along here, and I've got my 0.05 minus 0.06, and I get negative 0.01x. Now I'm doing it a little bit different than the book. So those go away. And I have negative 0.01 equals 560 minus 600. And because both sides are negatives, I can just make them positives. And then at this point, oops, there's an X here. Sorry about that. I'm going to divide by 0.01. 0.01, those go away. And then I have 40 divided by 0.01. And that gives me $4,000. So what in the world does that $4,000 represent? It represents how much money I invested at 5%. And the $6,000 would be how much I invested at the 6%. So do those two add up to 10,000? Yes, they do. So I'm good to go. So I'm going to close out this video and start 2.3 B as in Bravo.